In this example, we are going to conceptually determine what is happening to either the electric potential energy of a charge or the electric potential or the voltage within a field based on different locations that we move between. So what we're going to take a look at here is we are going to look at the electric potential energy of charge A, charge B, and charge C. The reason we're looking at electric potential energy and not electric potential, better known as voltage, is because we have charges, and the charges physically possess the energy while the field possesses the voltage. So if we take a look, and I look at that first charge, charge A, which is a positively charged object, I'm going to move that charge upwards in this case. So I'm moving it away from the negative plate and towards the positive plate. Now that is not what it naturally wants to do. Naturally, the positive plate would repel it downward. The negative plate would attract it downward. So the natural motion for this positive charge would be downward. I'm doing the opposite. And since I'm doing the opposite of what it naturally wants to do, we hopefully realize that I am increasing its potential energy. If we take a look at B, it's a very similar situation. Now it's a negative charge and I'm moving it downwards. Well, naturally, the negative plate would repel the negative charge upwards. The positive plate would attract that negative charge upwards and it would move upwards. I'm forcing it downwards, doing the opposite of what it naturally wants to do. So once again, I'm increasing the electric potential energy of that charge. In case C, if you take a look, I'm not actually changing really anything about its position. I am not moving it closer or further from the negative or closer or further from the positive. It's kind of like holding something out in your hand in a classroom and moving it side to side. You're not changing the height of that object, so you're therefore not actually changing the potential energy that it possesses relative to the ground. So I'm not really doing what it wants to do or what it doesn't want to do. Therefore, there's no change whatsoever in the amount of electric potential energy that charge C possesses. Now, in the second case on the bottom, we have an electric field with 5 different points, A, B, C, D, and E. And we're going to take a journey through here. We're going to go from point A to point B, then slide down to point C, up to point D, and over to point E. And the question is the voltage, or the electric potential. Is it increasing? Is it decreasing? Is it remaining constant? And that's what we want to look at. Now, there's no charges, which is why we're dealing with a voltage. The voltage is a property of the field. The locations have voltage. So as I'm going from A to B, we have a problem here. We don't have a charge, so how do we even know if this is a region that something wants to or does not want to naturally be in? And we have to fall back on our old friend, the positive test charge. There is no charge here, but we say to ourselves, if I were a positive test charge, is A a region that I would want to be in? And we say to ourselves, yes, I would love to be right next to a negative plate. So A is a region that a positive charge would very much like to be in. B is a region right next to a positive plate in which a positive test charge would not want to be. It would be repelled like crazy. So we say I'm going from a region in which a positive test charge would like to be, would prefer to be, and I'm moving into a region where a positive charge would not want to be. So that tells me that I'm actually increasing my voltage. I'm increasing my electric potential. When I go from B to C, it's the opposite. I'm going from a region that a positive charge would not want to naturally be in towards an area, towards a region that it would want to be in. So since I'm allowing, or I'm going between regions that a positive charge would naturally want to flow between, we know that that's a decreasing. Just as if I was lowering a positive mass and it had less energy, well, the regions themselves are providing that lower amount of energy. From C to D, you hopefully realize it's an identical situation between A and B. So once again, we're increasing because we're going from a region where a positive test charge would like to be to one where it would not want to be. And last but not least, when I go from D to E, I don't get any closer to the positive. I don't get any closer to the negative. I don't get any further from either. So there's no change there because I'm not actually changing anything about my position relative to these two plates.